Hermes is an Eclipse plugin for students in computer science courses. It does many things and can be extended to do many more, but its two main goals are to allow instructors to provide remote help to struggling students efficiently and to increase students' engagement and success with the course by providing them with metrics about their programming activity and how it relates to their peers. Hermes essentially collects information from a student's programming environment and sends it to a server for processing. The server condenses this information and leverages services such as Facebook and Google Docs to present it in a useful way to both instructors and students themselves. Let's look at several things Hermes currently does. It provides a simple UI where students can self-report the difficulty they are experiencing, as well as explicitly request help. Additionally, the Hermes server has an extension which allows it to publish to a course Facebook page. When a student requests help, a message is posted on the page's wall, which is visible only to instructors, with the student's information and help request. By looking at the page's feed, an instructor can quickly see who needs help and proceed to gather information to help them. The ability to post to Facebook also allows for useful information to be displayed to students. By aggregating the reported degree of difficulty students face, difficulty versus time graphs can be constructed for the current assignment, and students can see how much trouble their peers are having. If an assignment looks to be hard, students may be motivated to begin early. Also, the simple knowledge of how many of their peers have begun work on an assignment may be enough to prod students to begin earlier, in the same manner that fitness watches have adopted the same concept of a status timeline to encourage healthier lifestyles in their users by showing them the activities of their friends. By interfacing with a popular technology like Facebook, Hermes has the advantage of its information being viewable through a mobile app and providing an already familiar UI to its users. Eventually, we hope to use the self-reported difficulty as a training set for machine learning algorithms, which will do automatic difficulty detection. Hermes collects the text in the code editor and tracks changes to it. The server uses this information to create a Google Doc, which mirrors the file in the student's editor. Both the student and the instructor have access to this file, provided the student allows this. Here we again see the power of leveraging existing technologies. Because it is a popular platform, a number of extensions exist to manipulate Google Docs. By interfacing with it, Hermes gains access to all of the features offered by these extensions, in addition to all the features already built into Google Docs. For example, there's an extension called Draftback, which allows anyone with access to a Google Doc to peruse all historical changes to it. If an instructor wishes to see where a student ran into trouble, they can open the file of interest and look at recent changes to it. As another example, Google Docs provides the ability to add comments to a document which are shared between viewers. At the end of an assignment, an instructor could provide feedback in the form of comments on the Google Docs corresponding to the code the student wrote for the assignment. In addition, Google Docs has a mobile application, so all of this information can be viewed on the go. In addition to capturing text from the code editor, Hermes also collects output from the console. The console contents are appended to a Google Doc unique to each student. Instructors can consult this file to see what types of issues students are facing. Hermes tracks how much time students spend coding and breaks this down into time spent on different assignments and classes. While this capability itself is useful, and hence why plugins exist that serve exclusively this purpose, for example Waka Time, it is especially useful when the information is aggregated across all students in a class and all classes in a department. Students are able to see how much time their classmates have spent on an assignment and compare this to how much time they themselves have spent on it. When deciding which courses to take, students could view objective information about how many hours of coding are involved for the typical student in a given course. This time information can be made even more useful when it is correlated with grading information. Students can see how much time is required of them if they expect to make an A versus a B. Since all of this information is contained on the Hermes server, an extension just needs to be written which utilizes it. This is one of the main ideas underlying Hermes: to make the information which is collected from the programming environment flexible and extensible, as well as to make the processing of that information flexible and extensible, and such that the processing of one extension is available to another. Hermes provides a communication system that allows instructors to engage with students directly in Eclipse. Instructors can send instant messages to students for issues that can be resolved easily, and they have the ability to do shared editing for more complicated problems. Let's look at a couple of scenarios that demonstrate the situations in which we imagine Hermes will be useful. Suppose a student is trying to concatenate two strings, but uses the wrong syntax and can't make sense of the compiler message, so decides to request help. An instructor can look at the student's console file and their code and quickly diagnose the problem. A brief message to the student should be enough to resolve their issue. Now imagine a student previously had a functioning sort routine, changed a few lines, and now it no longer works. Frustrated, they request help. An instructor can look at the history of the file, see where things went wrong, begin a shared editing session, and help the student resolve the issue. Let's move from looking at the helping features of Hermes to looking at the information features. Perhaps an instructor is taking the bus into work and wants to see how many students have begun work on the latest assignment. They can open the Facebook app and go to the courses page and see a histogram of the amount of time students have spent on the assignment. Or let's say a student is trying to decide whether to work on an assignment or go to a social event. They can check the course's Facebook page and see how much difficulty their peers are having with the assignment and how much time it takes to complete on average. Hermes, both the Eclipse plugin and the server, were designed to be extensible. The base plugin simply connects to the server and exposes a method that allows extensions to send JSON and to receive JSON from the server. Collecting editor and console contents, time tracking, and measuring difficulty all happen in extensions to the base plugin. These extensions are easy to write and can be written by anyone. So if Hermes is lacking a feature you want, you can add it yourself, and your extension is able to use any of the features which exist on the server. So, for example, your extension could create and manipulate Google Docs without you having to write any code to handle this. The server is similarly designed. The base server simply sets up a connection which handles messages from clients. The rest of the functionality of the server, like interfacing with Google Docs and Facebook, happens through extensions. So if the server is lacking a feature you want, you can add it yourself, and your extension is able to listen to any messages which clients send. So, for example, your extension can receive time tracking messages and make histograms that show what times of day are popular ones for students to be coding. It could then leverage the Facebook extension to post these graphs to the course Facebook page. Hermes was designed in such a way that it is in no way bound to Eclipse. It sends information about the programming environment using the XMPP protocol. So in theory, anywhere where an XMPP connection can be created, an implementation of Hermes can exist. For example, we have implemented an experimental version of Hermes that is a Chrome extension that works with online IDEs. The server side remains exactly the same as for the Eclipse version because the XMPP messages are exactly the same. Hermes is even more general. It doesn't have to be used as an educational tool. It is a tool for collecting data from many devices and aggregating this data in a useful way, as well as providing a way to communicate with the devices. To demonstrate this generality, we set up a microcontroller to work with Hermes. To show its capability of collecting data from a physical environment, we wired up a button, and to demonstrate its ability to receive information, we wired up an LED. When the button is pressed, it sends a message to the Hermes server. This information can be used to append a line to a Google Doc, using the Google Docs extension we saw earlier. JSON can be sent to the microcontroller from any XMPP instant messaging client to control the LED.